Hello everyone, and welcome to the IEEE RAS Solidworks series. Today we're going to be talking about Module 1.6, Mechanical and Robot Chassis Design. So, chances are, if you're watching this video, you're probably wanting to learn a little bit about robotics, but also you might be participating in a robotathon competition. If so, this video will be especially useful to you. Right? So, one of the things we want to look at is if you're designing a robot, what are all the different things you got to consider whenever designing a chassis or a main frame for your, a primary frame for your robot, right? So due to the lack of time that we'd have to fully craft everything on the screen, what I do is I have preset parts, right, that is going to be made into assembly, and I'll kind of walk you through the step of everything along the way. So what we have here is we have the basic we have the base of our robot that we're going to be making, or kind of assembling here, right? You'll see it looks kind of basic, almost looks like a kind of a bin, right? But it has a little kind of slots in the sides and so on, right? Well, as we go along, you're going to see what all these different parts are and what we use them for, and what these actual modules are for. So one of the things is, if you're thinking about a robot you might make, right? There's a couple main components that you probably want to be thinking about, right? Is one, how is your robot going to move, right? Especially if you're doing robotathon. In that case, you got to think of, are you using treads, are you using wheels? How are you moving, right? How do wheels move? Wheels get turned by servos, which convert electricity into mechanical energy, which turns the wheels, and so on. Right? What controls the servos and the motors? That happens via a microcontroller, right? For example, what I'll be using as an example is the TM4C from Texas Instruments, right? Now you can have this microcontroller, little mini computer be controlling things, but the main thing is all that runs on electricity. How do you get electricity? You need room for a battery, right? So as you can see, the list of things goes on, right? So throughout all this, as this video, I'll be showing you all these different components and all these different considerations you have to be thinking of, right? So looking at this right here, right, it's just an empty space, right? But as I put objects in, you're going to see that everything in this little space has been planned out so that way the objects fit nice and snugly, right? So that way everything is kept in within the robot very well and nothing's moving around too much, right? You want your internals to be well taken care of. A well-designed robot has good internals, everything is organized, right? Last thing you want to do is short circuit any kind of robot or make sure that everything is not connected properly. Alright, so I think I will first start off with the servo motors, right? So I'm going to go ahead and file, or actually first I need to make an assembly. So forgive me about that. So I'm going to go ahead and go to our assembly here, right? And what I'm going to do is I'm going to go ahead and click Insert Components, right? So I want to insert in a component. The component I'm going to insert in is, let's go and enter it in the base. Only makes sense that our base be the primary center of our robot. Great. Right, but of course I'm going to need more components. So I'm going to go ahead and insert some components that I have prepared beforehand. So let's go ahead and browse, and I'm going to go ahead and add in, let's see. You may not see this File Explorer, but I have the File Explorer open right now. And I'm going to go ahead and add in a servo. Right, so this is in Spanish. I got this off of GrabCAD, right? So GrabCAD is a, in short, it's a library of CAD items. You can find many kind of manufactured parts. That way you don't have to CAD everything you use beforehand. It's a great resource. I recommend you check it out. But it just so happens that more than likely, the person who created this speaks a different language. Right, and so I could rename that if I want to do just servo assembly, but you can kind of see what that is there. So I'm going to open up this servo, and look at that. I got a servo, right? And this is actually an assembly. So one thing I might have not explained before is when you're working in an assembly, you can insert in sub-assemblies, right? So this is actually two parts. The little pinion that you see above, and the rest of the servo with the wires connected below. So I'm going to go ahead and add this in. Great. Let's go ahead and let's go ahead and move this in. So what I want to do with this is I'm going to go ahead and rearrange myself here, place it down, and just kind of wiggle myself around here and place it out here. Great. So the reason why is if you look at the servo, right, when you're looking at the most basic kind of servos, right, they have the body of the servo, which is almost just like basically a box, right? And then they have this outside part right here, right? These little holes are where you typically use screws of some sort of mechanism, right, of holding this servo into place, right? Because your servos are typically going to be fixed. So if I wanted to go and insert this servo in, kind of back out a little bit, and if I want to mate it, usually the best option is to take your rotate component tool and rotate your object into place, much like you'd actually see it whenever you're actually going to mate this into place. Just general rule is this is the best way to make sure that all of your mates are oriented the right way, because your mates work via Solidworks taking those two, either like two faces, two edges, a face and an edge, and making sure that those are connected and it automatically makes a jump. Right, so we just want to make sure everything works out. Best thing is to orientate your parts the way they might be mated in the future. So the first thing I think I'm going to do is I'm going to go and start off by mating the face, the bottom face of this servo, to the actual base there. Great. And if we look, I can kind of rotate this all around now. And I'm going to move it outwards just a little bit so it's easier to move. Great. So I got that face. Let me go ahead and mate the two sides, right? Because what I'm doing right here is I'm fitting it into this slot. And that's actually what our slots here are for. They're made to house servos. So I'm going to make sure that's in, and now you can see I could slide it in if I wanted to. But the basic easy decision would be to take our mate this face with the face that it's going to be connected to. Right? A little check mark. And now we have a servo that's excellently fixed into place. Great. Right? And then if you wanted to, screws would be able there to fix those in, however your manner of adhering it to the surface would be. Now, of course, we are going to have to repeat that. So let's go ahead and go over here. And let's go ahead and exit out of the mate menu and go and insert a new component. Just like before, I think we're going to need another servo. So I'm going to add a servo, go through this a little bit more quickly. I'm going to use my rotate component, rotate it like this. And then I'm going to quickly go through the mates, just repeating the same ones as before. That surface to this surface, because typically how I've made it is that way it can fit in. I'm going to go ahead and mate the bottom surface to the bottom plane. Right? And just remember, you don't have to click exactly in the right place, but as long as you're picking the exact overall surface, these mates will work out really well. And then I think I'll go ahead and mate this plane with this plane. I could have chose the other side, but in the end it doesn't matter as long as the results are the same. Great, now I have two servo motors plugged in. Right, you can see where there normally servo motors would have a ground, power, and signal wire being what controls it, power giving it actual energy, and the ground wire, which is all part of basic circuits. Right? It would be very important to have those pointing outwards and having room for them this way. Right? We can all imagine that it really wouldn't work if I tried to put those wires on this side, right? They would bump into something, they want that free space in order to move back to the rest of your circuitry would be. Right? And of course it makes sense then here to make sure that everything is set up properly and that it's all connected. Great. So what I'm going to go ahead and do now is let's look about maybe adding in our microcontroller. Right? So let's go ahead and click the X button. Right? And also actually one thing I should mention quickly before is if I zoom in here, you're going to see a little bit of space. You'll see that? Right? There's a little bit of space on the top, and if I kind of revolve around here, you're going to see a little space there, right? So that's just me roughly accounting for something called tolerances, right? You'll learn about this more if you're a mechanical engineer, but in one of your ME302 classes. But tolerances are basically kind of a little bit of a measurement difference that happens when you manufacture things, right? So due to the nature of 3D printing plastic, which I would probably 3D print this kind of base that you can here see in red, right? Those printing materials might actually expand, right, during the cooling process, or as they get laid down, they might slightly be misshapen. Point being, though, is that if you design this motor, right, to be a certain size, say certain millimeters by certain millimeters, and then you make it exactly right next to it, right, you won't actually be able to fit the servo motor in. And that's the big thing, because even though you would think, oh, if this is, if say the servo motor is 15 by 30 millimeters, right, if if I made the slot 30 by 15 millimeters, it would be so tight of a fit that you actually wouldn't be able to fit it in. So it's important that you make sure you account for a little bit of extra room whenever you have in-slotted components like this. Just something to be aware of, right? How close do you need to make these fit snug? That's very objective, right, depending on what you're making. What I would recommend is try making little slots of 3D printing, right? Experiment using the makerspace, or Texas Invention Works as it's now called, and just try and see what fits, what doesn't, right? See how much the printing material expands or contracts during cooling or heating or whatever you use, right? It's a great idea to experiment with those things firsthand. You'll be able to see a lot better if it's like 1/100th of a millimeter or a 1/5 of a millimeter, however much it takes for that difference to be. Okay, so now what we're going to go ahead and do is I'm going to go ahead and insert some components in. I'm going to browse, and let's see, let's add in the TM4C. Right, and these are all models I said, of course, later that I got off of GrabCAD. So place it in there. This is very basic microcontroller, right? In the middle is the processor, a reset button, power button, little micro USB port where you usually power the board, or what they call flashing code onto the board, right? You got to be able to take your computer and use a little mini USB cord to put it on there, right? So if you're building a robot, maybe it'd be good to have that port be accessible, right? So what I'm going to go ahead and do is just moving it around. I'm going to go ahead and do a quick mate, and I'm going to do a very simple mate where I get real close here. In this bottom of this little board here, I'm going to go and mate that section to the bottom of this whole section here. Great. Right, awesome. Now we can look around, right? It's not quite orientated the way I want to, right? That's actually why this slot right here is made, right? So I can have easy access to the micro USB if I ever want to flash on new code to the robot without changing the internals. It's a great little idea that you can do, right? All these are little things you got to think about when building your robot, right? Is there enough room, right? What I did is, now you might do this with calipers. You have to measure all your parts and pieces, see how much space they take up, right? In designing this chassis, I wanted to make sure that everything I was making could fit within it. And that means, you know, I need to know the dimensions of this microcontroller, right? How do these motors fit in? How much room do I have? All of these have to go in line. You got to think of total length, slight additional spacing. It's really kind of a trial and error sometimes, right? So maybe even just placing these components in a basic pre-testing assembly and then checking for measurements and how spacing looks like is a great idea. But sometimes you'll have these physical parts and you need to make an example CAD of them. Or maybe for these motors, I would just create a rough shape that kind of looks like them. Right? All of these will really help you kind of outline what your robot will look like whenever you're finished. So I'm going to go ahead and I'm going to rotate this component, right? I really want to make sure that this thing, let's kind of adjust it. There we go. That's good. Rotating is kind of weird since my angle. There we go. Perfect. Alright, so I'm going to go ahead and adjust this a little more. And as you can see, I've rotated it, but I want to make sure it's, just for niceness, I want to make sure it's perfectly orientated against everything else. So I'm going to go and make a new mate, right? I'm going to mate this plane and this plane. However, I don't want to make sure they're connected there, because then they'd be right in the middle of the servos. What I'm going to do is I'm not going to make a coincident mate, I'm going to make a parallel mate. Right? So now these two planes are parallel, right? Which means I cannot rotate them and it's perfectly fixed. Great. And I'll kind of leave it connected about here. That's great. And now we can see there would be room for you to plug in your mini USB in this little slot, right? And you would be able to change the program of your robot on the fly, which is great. Perfect. So that would be in there, that would be fixed in, and now normally, if like sometimes, right, in this case, I could put mounting on here, right? I'm probably just going to leave it like this because the compact nature of my robot will secure everything pretty well and it's not moving around too much. But if you wanted to, you could add in some extra inserts on the bottom, maybe tighten up the space, make it so that way your microcontroller just fits in, is snug, and nothing will move it, right? It's totally up to design decision for you. But for this simple design, we're going to go with that. Alright, cool, I've kind of set that in there. And if I really wanted to, what I could do is I could go ahead and right-click on this, and I could fix it, right? So I just fix this object, And that means no matter what I do, I cannot move it, right? And I can always just right-click and float instead. And if I float it, you'll see now that I can move the object around, right? It's always good to fix things in place, right? Mating is just a way of attaching things and putting them into place, but fixing just makes it impossible to move them, which is very handy. So of course we've talked about, devices, what controls the devices, and then finally, battery, right? So batteries are often something you have to consider, right? I'm going to go and insert components, and I'm going to go and click browse. So you might not see this file folder, but I'm going to add in a 6AA battery holder, which is more than likely if you're in a robotathon or working with small robots, this is something you'll probably use. So I'm going to go ahead and you can see how this all works, right? Different sections for what would be your batteries. You'd have a little cable that comes out that connects to your board, right? All that's kind of down there. So I'm going to go ahead and zoom out, and I'm going to rotate this around, because as I've said before, it's always helpful to rotate your components the way you'd want to place them down in your assembly. There we go. Looks great. It's kind of in place there now. So let's go and start with a couple things. As we said before, let's mate. Always best to mate on the plane first. So I'm going to go ahead and select a little plane here. Select the bottom plane. Great. Now a little thing right here is, let's go and readjust our little camera angle here. Always helps. It's kind of at a weird angle, right? So we can always fix that. We could rotate it 7,000 of hours, but that's where mating comes in. It's very helpful. I'm going to take this plane and this plane, right? We don't want to orientate it so where it's coincident planes, we want parallel planes. And honestly, that just makes everything easier. Now I can move it around and put it into place. Right, now I'm discounting a few things, right? Depending on the complexity of your robot, you might need a breadboard, right? So you need to make extra space for that. A breadboard is something, it's just a little piece of like silicon, right? Plastic, that has a lot of different kind of metal connections, right? So you plug wires into it, and it's just a way of really compacting your circuit. So all the wires would go to the breadboard, they connect all in this little board, and then go outwards, right? So it's just a little tool. So as you can see now, we have all these little different components of the robot, right? Of course, we're not done yet. We've kind of got the internal hardware, but there's external hardware we might want to worry about. So I'm going to go ahead and exit out of this little main menu, and I'm going to insert components, browse. I'm going to go and add in some wheels. I'm going to go ahead and insert in another component while we're at it, which is a secondary wheel. Let's not worry about it too much, but it's just a way of getting things out of the way. Right, and so if you're working with a servo motor for a wheel, you'll take a look. There's a little pinion, a little slotted, kind of teethy, sharp little section here, right, that fits in, and does just like a little gear, and ends up spinning everything. You saw a little reminder on the bottom right. I haven't saved my document. Let's go and just click Save All. Rebuild and save the document. Always a great idea. Oh, let's name this. Let's name this Solidworks. Oh, let's get there. Solidworks Series Assembly. Works great. Right? Perfect. So let's go ahead and orientate these again. I'm going to, just a reminder, right? Always a great idea to reorientate yourself. Makes it a lot easier to rotate things or move things. So I'm going to rotate this like that, kind of move it in place how it might look as a wheel. I'm going to also rotate this piece as well. Perfect. Right? Always a great idea to rotate things how they might look whenever you're working with them. Kind of place. Okay. So if we wanted to attach this wheels, right, let's kind of think about how we've done before. So I'm going to click on Mate, right? As you can see, right, there's this edge right here. Now, because I haven't designed these parts personally, I'm not sure if these two things are exactly the same. They kind of don't look like that, right? There's a little bit of a discrepancy in people, how they design it. Right, so we're just going to go ahead and stick with some cylinders. Let's go and make sure this is lined up along the axis. You could take this circle and made it to, this cylinder and made it to the other cylinder. Right? So what we could do is we could make sure this is concentric. Great. And now you can see, because there's two cylinders, it's restricted, not in rotation, but it is restricted along the axis you could put it in. And if we were going to go ahead and fit this on, what would probably happen is we're probably going to mate this side right here, and it would go all the way to, let's just make it there. Might look a little tight, right? Normally your server wouldn't go on this much, but that's alright. For visual purposes, it's easy to understand. Right, so now you can see I can rotate the wheel. I fixed it in place, and this is pretty much exactly how your wheel would look like. Now, let's look back over here. We'll do the same thing with the wheel real quick, and I'll make this pretty quick. So I'm going to go ahead and fix this little wheel section right here. Actually, let's not start off with it. Good idea is to get the component orientated first. So I'm going to go ahead and orientate this drum or cylinder, surface area, lateral surface area, the lateral surface area, really any of these. I'll pick this one. Why not? Oh, I think I accidentally did not click the right button there. Let's go and try that again. I'm going to make this section over here with another cylinder. And this time we're going to hit check mark instead of X. There we go. Now it's kind of lined up along that axis. It'd be very easy just then to mate again this flat side with this flat side of that motor, and you kind of see where it was. And you could offset this if you wanted, but for the purpose of this course, I'm not going to offset anything at the moment for time. Great. And I fixed this in place, and I think I'm going to go ahead and fix this into place. Or, once I get rid of the mate, of course. I'll go ahead and fix this whole thing into place. Great. Alright, so as you can see, I've fixed everything into place. Everything's kind of locked in place. Great. Right, so this is kind of what a robot looks like so far, right? It has a place for a battery section, right, and so on, right? All of your internals are in there securely. Now, of course, if you want to safeguard your internals, something like a cover would be a great idea. So I'm going to go ahead and insert in components. I'm going to go ahead and browse, and I believe I have a cover that might work for this purpose, right? How you fix this cover is up to you, whether it's glue. Now, if it's glue, you can't take it off, of course. Whether it's something like a pressure fit, where it's just a slot, that would work really well too, right? It's kind of up to you how you decide to do this. And I made this transparent, right, so you can see the inside later on, but it's totally up to you. So I'm going to go ahead and click Rotate Component, spin it around, there we go. It's close enough. Now it's kind of oriented the right way. Let's go and start by mating a few things first. Let's go ahead and made a few things here. There we go. So I just made this corner right here, and I think now I'm going to readjust a little bit, and I'm going to mate this edge right here with this edge right here. Perfect. So now you see with those two edges, actually, I managed to fully define this entire section. Let's go ahead and exit the mate. You can see if I try to move this, it's fully defined, it cannot move, right? Perfect. And now you can see the inside of the components, right? Imagine that was a pressure fit. You could just do a little latch or something. There's tons of different ideas you could do. Point being, though, is that this will allow you to kind of lock everything into place. Now, you could just have the robot just like this, right? It would drag, right? You'd have the two wheels. That would allow you all the motion you'd want, right? It could totally crawl forward. For Robotathon, you have lots of different options. You could probably get other freestanding wheels that you could attach to the back, right? One common idea is a small roller you can attach on the back. I'm going to leave this empty. Kind of, you can fill it in with your imagination, what you believe would work best for whatever task you have, right? One thing about Robotathon is you don't know what it is. Nobody knows what it is, right? It's a secret task. So you'll see later on during the kickoff what the task will actually be for the competition, but you really don't know. So try to think up some ideas. What were you trying to do? You're trying to move this around, be quick, be agile. What are you trying to accomplish with your movement system? It's always a big consideration for you, right? So you have all these different components in, and it finally kind of wraps it up into one clean picture, right? And after all, right, if you edit these wheels, right, you control one to allow you to turn, you can vary the different steering abilities. All these wheels kind of placements allow you to move around a whole lot better, right? And one additional thing is you've seen all these parts as well. One little trick is if you're making your own projects, you can often find, like, say, Pololu makes a lot of things like motors and a lot of other different kinds of parts and pieces. Often on their websites where you would buy the parts online, there's often a section that has CAD files of the exact replicas of what you're working with, right? So it's often a great idea to, if you're purchasing something, try looking at what the CAD is, right? All this is going to be a great amount of stuff that can help you. With that, that pretty much covers everything for this SolidWorks series, so congratulations. You've made it to the end of the SolidWorks series, and I hope you have a wonderful time in IEEE RAS, or any other organization regarding robotics, or anything regarding mechanical as well. It's up to you what you decide to do, but either way, we're glad that you have this knowledge now. Thank you so much, and see you next time.